Hi everyone and welcome back to Maths and Physics with assignments. It's grade 11 analytical geometry. We're looking at a parallelogram related problem. It was in November 2015 exam. So pay careful attention to this problem. We've used this problem various times to catch out many a learner. So I'm doing it and I hope I do justice to it. Please like and subscribe if you're following and you're understanding what I'm doing. Feel free to comment. Right, so let's look at the problem. So November 2015, they say in the diagram below, the line joining Q and P. So there's Q and P, Q being -2 and -3, and PAB, A and B are both greater than 0, meaning they are in the first quadrant. They're both positive. Makes an angle of 45 degrees. So when I give you an angle, that's normally to find the gradient of that line with the positive x-axis. QP, so from Q to P there, is 7 square root 2 units. N is 7 and 1, is the midpoint of PR. So it cuts that line in half. And M is the midpoint of QR. So M cuts QM and makes QM and MR the same length. So number 1, determine the gradient of PQ. So there we're going to use the angle. Then we want the equation of Mn in the form y equal mx plus c. So I assume you still remember your grade 10 midpoint theorem. That if that line there cuts in such a way that that two sides are the same and that two sides are the same, then this line must be parallel to that and it must be half the length of that. Right, so the length of Mn, then they want the length of Rs. Right, now there they say the coordinates of S such that PQRS orders a parallelogram. So a parallelogram automatically then means RS must be the same length as PQ. And then we want the coordinates of P, the special problem, because now we have gradient given there and we have length given. So I'm going to have to use that 2 to solve simultaneously. Alright, so let's start. Gradient of PQ, so on the line PQ from the x-axis and make contact there, we have 45 degrees. So my gradient PQ must equal the tan of 45 degrees. Tan of 45 equal 1, so my gradient PQ equal 1 unit. Right, 1 mark there for tan 45, 1 mark for 1. Number 2, they want the equation of Mn in the form y equal mx plus c. So as I say, Pn equal Nr, Rm equal Mq. Therefore, Mn is parallel to PQ, and my reason would be midpoint theorem, 1 mark. Therefore, if the gradient of PQ is 1, then the gradient of Mn must also be 1 because these two lines are parallel. Assume you remember, two parallel lines have the same gradient. So y equal mx plus c, so gradient is 1. We want the equation of Mn, so on M and N we only have the 0.7 and 1. So according to this, x is 7 when y is 1. If I take 7 across, 1 minus 7 would give me -6, so c is -6. So equation of Mn equal y equal x minus 6. So 1 mark for midpoint theorem, another mark for the gradient, 1 for correct substitution, and 1 for the correct formula. Alright, going to the next question. I hope you follow what I've done there. Alright, so for number 3, they want the length of Mn. Right, so according to the midpoint theorem, Mn is half the length of PQ. So Mn equal half PQ according to the midpoint theorem for 1 mark. So PQ is 7 square root 2. I'm going to divide by 2. So 1 mark there for knowing that it's half the length of the longer side. And there dividing by 2 for the correct answer. To get the length of RS, because in 5 they say this is a parallelogram, RS equals PQ. Because it's 1 mark there, RS is simply 7 square root 2, no reason needed. Alright, now we're going to the last 2 more complex questions. The coordinates of S, such that PQRS is a parallelogram. QN equal NS, so there they say QN equal NS, diagonals of a palm bisect. So there you see I have P and R, it's a diagonal, and Q and S is also a diagonal. So we should know, according to the rules for parallelogram on its properties, the diagonals bisect at the same midpoint. So therefore QN is the midpoint of QS, so that QN equal NS. So I have Q minus 2 and minus 3. S because I don't know it's X and Y, and my midpoint 7 and 1. So you see under the triangle I use this. Under the rhombus, same problem now again. So we should know x1 plus x2 divided by 2 is to get the middle. But now we have an answer for the middle. It equals 7. Right? Then y1 plus y2 over 2 must give me 1 because we already have the answer for the midpoint. So if I substitute here, I have x minus 2 divided by 2 equals 7. And I have y minus 3 divided by 2 equal 1. We always multiply the denominator way, so that becomes 7 times 2, which then gives me 14. There, 1 times 2, which then gives me 2. So that leaves me with x minus 2 equal 14. If I take 2 over, 14 plus 2 would then give me 16. There, 2 times 1 is 2. Leaves me with y minus 3 equal 2. And if I take negative 3 over, 2 plus 3 then gives me 5. So 1 for understanding that the midpoint must be 7 and 1. And 2 marks for the correct answer. Alright? So hope you understand. As I said, we always test this. Make sure you understand how to do it. How to use the midpoint and another coordinate to find the unknowns of another coordinate. Right, now let's go to question number 6. The coordinates of P. So we want P, A and B there. We don't have the equation of PS. Right, I can't use PR. Right, but what's given to me, I worked out what's the gradient of PQ, PQ being 1. And I also have the distance of PQ, which is 7 square root 2. So gradient PQ equal 1. That means the equation for PQ would equal y equal 1x plus c. And on PQ I have the point minus 2 and negative 3. So according to this, y is negative 3 when x is negative 2. If I take that over, minus 3 plus 2 gives me c negative 1. So the equation of PQ, y equal x minus 1. Right? Now P is A and B. So A here representing x, P representing y. If I take 1 over, I can make A the subject of the formula, or I can leave P as the subject of the formula. I chose P. So if I take that over, it becomes P plus 1 equal A. That's my equation 1 based on the coordinates of P. PQ, to get the distance, is square root x2 minus x1 squared plus y2 minus y1 squared. Right? Get rid of that. I can say PQ squared equal. Now remember my x2, A. So A minus minus 2 all squared. P minus minus 3 all squared. That would become A plus 2 squared and P plus 3 squared. But I can substitute 1 in, so I know A is P plus 1. So instead of having 2 unknowns, now in the place of A, I put P plus 1. Plus the 2. And there I have P plus 3. So my whole equation only has P in it. Alright, PQ, there is 7 square root 2 all squared. Alright, so PQ, we should know is 7 square root 2. It was given to us. So there, if we square 7 times 7, 49. Square root 2 times square root 2 gives me 2. Right, that's P plus 3. So P times P is P squared. P times the 3 gives me 3B times 2 gives me 6B. 3 times 3 gives me 9. I assume 1 plus 2 is 3. There again, p times p gives me p squared. P times 3 times 2 gives me 6b. 3 times 3 gives me 9. So if I add b squared plus b squared gives me 2b squared. 6b plus 6b gives me 12b. 9 plus 9 is 18. 49 times 2, which is 98. If I take it over, becomes minus 98. 18 minus 98 would give me negative 18. So if I divide everything by 2, 2b squared divided by 2 gives me b squared. 12b divided by 2 gives me 6b. And minus 80 divided by 2 gives me negative 40. Now I have to use the factors of 40 to get to 6. So b squared is simply b times b. 40, 10 times negative 4 gives me negative 40. But 10 minus 4 also gives me 6. Now, they said a and b must be greater than 0, so b can't equal negative 10. If you look at b, it's in the positive first quadrant, so therefore p equal 4. If b is 4, 4 plus 1 gives me a equal to 5. Therefore, the coordinates of p is 5 and 4. So I hope you followed what I've done. I hope you enjoyed the lesson. Like and subscribe. Show you practice this problem properly. This is a nice exam problem, and as I said, it's one that we like to use, and I've seen in various papers from different schools helping learners where they still catch learners out with this exam problem. God bless. Bye.